In this video, I'm going to be going over the 6.1 to 6.2 quiz review. I have a few questions that want me to simplify, factor, and then verify each identity. So on the simplifying ones, I'm trying to get it into the smallest number of terms as possible. And this one, I have 1 minus sine squared on my numerator. So over here, I have this Pythagorean identity. I can rewrite this. So I'm just going to copy this down. I can rewrite this in terms of 1 minus sine squared. I can move this over. So it's going to give me cosine squared equals 1 minus sine squared. So that means I can replace my numerator with cosine squared. Then I want to look on my bottom for cosecant, and I have cosecant equals 1 plus cotangent. So I'm just going to plug that in for my cosecant. I have the 1 plus cotangent squared x, and then I had the minus 1 from here before. Then I just want to go ahead and simplify. So I have cosine squared. The 1's will cancel out because I have 1 minus 1. Gives me cotangent squared. I have cotangent on the bottom of the fraction, so if I look at my reciprocal identities, cotangent is the reciprocal to tangent, so I can rewrite this as cosine squared times tangent squared by using my reciprocal identities, and then I can rewrite my tangent as sine squared over cosine squared. So since I have a cosine on the top and bottom, I can go ahead and cancel those out, which will leave me with just sine squared for my final answer. It's one term, so I'm good with simplifying. On number 2, it wants me to simplify sine beta plus tangent beta, or sine beta times tangent beta plus cosine beta. I'm going to first, since these are 3 different trig functions, I'm going to try and rewrite them as all sine and cosine. So I have sine of beta times sine of beta over cosine beta. Remember, this is coming from my quotient identity, that tangent is sine over cosine. And then for now, my cosine is going to stay the same. I want to go ahead and multiply out front. So it's going to give me sine squared over cosine beta. And then my cosine beta is not changing. Then I want to be able to add these together, so I need them to both be fractions. To turn this into a fraction, I need it to be over a denominator of cosine beta. So I'm going to multiply by cosine beta over cosine beta, which will give me sine squared beta over cosine beta plus cosine squared beta over cosine beta. Now that they have the same denominator, I can combine the numerators. So I'm going to have sine squared beta plus cosine squared beta over cosine beta. Then if I look back at my identities, sine squared plus cosine squared equals 1. So I'm going to replace my numerator with 1. I have 1 over cosine beta. I don't like fractions, so I want to take a look and see if I can do anything about that. 1 over cosine is secant. So my final answer here is secant beta. Okay. Number 3 wants me to go ahead and factor. Looking at this one, I see that I have sine squared in both of my terms, so I'm going to pull that out for now. Okay, so that gives me sine squared x. And then my first term, if I pull out a sine squared, it leaves me with cosecant squared. And then sine squared divided by sine squared gives me 1. This one is still a difference of squares, so I can go ahead and factor it more. The sine squared stays out front. It's a difference of squares, so I can have cosecant x plus 1 times cosecant x minus 1. Now that I don't have any more exponents inside my individual factors right here, I am good. This next one wants me to factor tan to the fourth plus 2 tangent squared plus 1. This is the same thing as if I had a polynomial in the form x to the fourth plus 2x squared plus 1. So I'm looking for what multiplies to 1 and adds to 2, and the fact that it has an exponent of 4 just means when I split it in half, I'll still have exponents of 2. So I'm looking for what multiplies to 1 and adds to 2. That is 1. So I'm going to have tangent squared plus 1 times tangent squared plus 1. Because these have plus signs in the middle, I cannot factor these anymore. I can leave it like this, or because they're two of the same factors, I can rewrite it as tangent squared x plus 1, and the whole thing can be squared like this. My last four are asking me to verify the identity, so I want to go ahead and change one side of my equation to match the other side. It doesn't matter which one I pick to start off with, but once I pick it, that's the side I have to keep working with. So I have tangent squared plus 4 equals secant squared plus 3. I'm just going to take a look at my identities because these look equally as hard here. I can replace a secant squared with 1 plus tangent squared, so that's going to be easier. So I'm going to change my right side. So my left side is going to stay alone. And then the secant squared is going to be replaced with 1 plus tangent squared. And then in my next step, left side stays the same. 1 plus 3 will give me the 4 I wanted. So I'll write the tangent squared out front. And both sides match, so I am done. On verifying identities, I only change one side of the equation, and the whole thing is my work. Okay, so on number 6, when I take a look at this one, I have a fraction on one side and multiplication on the other. Fractions are they look more complicated, so I'm going to start with the left side. That means my right side is going to stay the same the entire time. I am going to, for now, leave the cosecant alone, but I'm going to use my reciprocal identity for my cotangent. So if I have cotangent on the denominator, it can move to the top and become tangent. My right side is staying the same. Then I'm going to go ahead and rewrite these. Cosecant squared is the same thing as 1 over sine squared. Tangent is sine over cosine. Then if I multiply these together, the sines will cancel out. So I have 1 over sine theta cosine theta equals cosecant theta secant theta. Then these are both on the denominator, so I can use my reciprocal identities. 1 over sine is cosecant, 1 over cosine is secant. So this will give me what I want. Oops, secant. So now that my sides match, I am done. Taking a look at number 7, this one has addition on the left and multiplication on the right, so I always want to deal with addition because that's more complicated than multiplication to get rid of. So I'm going to rewrite these. Cotangent is cosine over sine, and then tangent is sine over cosine. And then my right side is staying the same this time again. Then I want to make it so my fractions have the same denominator. So this one is missing a cosine. I'm going to multiply my top and bottom by a cosine, which will turn that into cosine squared. And then the bottom into sine alpha cosine alpha. Over here, this one is missing a sine on my denominator. So I'm going to multiply the top and bottom by sine. That's going to give me sine squared alpha on the top, and then sine alpha cosine alpha on the bottom. Right side is staying the same. then I can add these two fractions together since they have the same denominator. That is going to give me cosine squared alpha plus sine squared alpha over sine alpha cosine alpha, still equaling cosecant secant. Then using my Pythagorean identities, I can have sine squared plus cosine squared equals 1. So I can replace that numerator and turn it into a 1. That is going to give me 1 over sine alpha cosine alpha equals cosecant secant. Then I just need to rewrite these using my reciprocal identities. Sine goes to cosecant. Cosine goes to secant. And my right side stays the same. And they match, so I am done here. Okay. Number 8, I have fractions on my left and not fractions on my right, so I'm going to start off by trying to get rid of those fractions. Tangent can be rewritten using its reciprocal identity of, or 1 over tangent can be turned into cotangent. And then 1 over cotangent can be rewritten using its reciprocal to turn it into tangent. And my right side stays the same. I can rewrite this just in the correct order that I want it so it matches perfectly. So I have tangent x plus cotangent x equals tangent x plus cotangent x. And I am done here. So this one was just using reciprocal identities.